Welcome back to C# Tutorials for Beginners. This time we're going to be doing access modifiers. Access modifiers are often considered a very hard subject for beginners, and I think that's because most of them are not applicable to beginner programming. And I'll show you why in a few minutes, but that being said, I'm going to explain what it is, and then I'm going to go in depth about the two important access modifiers for beginners, and then I'm going to give you a little bit of explanation of the other ones, just in case maybe you're going for an entry-level job interview where they're going to expect you to know what they are. So first I'm going to create a new class by going to add new item, class, and then I'm going to call it person, just like last time. I'm going to get rid of my using so we don't have to look at them. And then I'm going to copy and paste this note data in here so we can reference it more easily. Now I'm going to add public string first name, public string last name, and public int age, as well as my public string get full name method, where we would return first name and last name concatenated together. Now let's jump back over to program, create a new person, and let's set some details. So we can set their first name, we can set their last name, and we can set their age. And then we could say console.writeLine person. We can call the get full name method to print the name of our person. Just like that. Okay, now we're all set up. So access modifiers themselves are used to define where the item, be it a class, method, field, or another kind of item, can be used. So let's jump back to person. We can see that our class has an access modifier on it. Each one of our fields have an access modifier on it, and our method has an access modifier on it. So before we jump into the difference between these, let's talk about why we need access modifiers. So access modifiers enable what's called encapsulation, and that is a core object-oriented programming concept. And what it does is it keeps data together with its relevant methods, which we saw in the last video when we decided to create this get full name method rather than accessing these two fields directly from a different class. The next thing is what's relevant to this video, and encapsulation is meant to restrict direct access to data to keep things simple and safe from unwanted modifications. For example, if we hop back to our program class, you can see that these fields here are set directly in another class. So if we got this information from a sign-up form, this would be fine, but then somewhere else in our code, we could say person.firstname, and we could change this. Now, while this isn't inherently a bad thing, and it may be what you need to do, many times you don't need to modify this field directly anywhere except for inside the class that it lives in. And then you have other methods that can use these fields to give you back what you need or change the fields if necessary. So that brings us to our first two access modifiers, and these are the most important modifiers for a beginner programmer. So first up we have the public access modifier, and that means it can be used in any class. So if you look here, we have a public field called first name. And if we go back to our program class, so inside this class, we're creating a new person object. You can see that this first name field is being set right here. And also, you could say string my first name equals person.firstname, and you could get the value out of the person class like this as well. And the only reason that you can do both of these get and set operations are because this field is public. So because we don't need to be able to get and set this information directly, encapsulation tells us that this is a bad practice because we are not safe from unwanted modifications to our fields. So to fix this bad practice, we're going to make use of the private access modifier, which means an item can only be used in the class that is containing it. So if we go to the person class, this was where first name is declared. So if we change public to private on both of these fields. And I am going to right click, rename, and I'm going to lowercase these because that is the convention that I like to stick to. And the refactor rename command changes your variable names everywhere they appear, so you don't have to worry about messing up changing everywhere they are. So now let's hop back to our program class and let's see what happened. So now we're looking at person.firstname and there's an error. Person.firstname is inaccessible due to its protection level. And that's exactly what we want, because these fields, we don't want anyone accessing or changing them directly. And that is how we encapsulate using the private access modifier. So now what do we do? Well, in this particular case, we could use what's called a constructor, but we haven't gone over that yet. That's in another video. So let's create a method called a setter. So let's go back to our person class. And what we want to do is create a public void method because we want it to be accessed from another class. We don't need to return anything because we're going to be setting a member variable, which is a variable that belongs to this class. And we're going to call this set first name. To do that, we want to take a string name, and then we're going to make first name equal name. And that's all we need to do. So when you call the set first name method, we're going to pass in a name, and we're going to assign first name to that name. Now let's do the same thing for last name. We want to set last name, and we want it to set last name. So now we have two methods that are publicly available that can very specifically set the first name. So if we hop back to our program, rather than doing this, what we're going to do is say person.setFirstName and person.setLastName, like that. Now this may seem a little unnecessary, but what this does for us is, first of all, now we can't access first name by itself. We have to call this getter, and it gives us the full name. The second thing it does is it makes us not be able to set this without explicitly saying set last name. So this can't happen. We can't change this without calling this method, so you prevent accidental unwanted modifications. So let's get rid of these 4 lines and go back to person. So suppose this get full name did something extremely complex, and these private variables here were very important pieces to this. If one got changed somewhere else by accident, it could break tons of logic in this class, which is one great reason to use encapsulation. So let's do the same thing for age. Let's make age private and rename it. And now let's create public void set age. We're going to take an age, and we're going to say age equals age. Now I named these the same on purpose to show you this. Assignment made to the same variable. Did you mean to assign something else? Because we are taking in int age and we're trying to assign it to int age, Visual Studio doesn't know that we're not saying that this age is equal to this age. Now, it's some people's convention to either prefix an underscore on private variables or postfix an underscore on private variables, so this problem never happens. Now, it is fully up to personal preference if you choose to name your variables that way. But what is important is that you are consistent. Make sure you use the same convention everywhere, or else your code is going to become really hard to read. So it's my preference not to use a underscore anywhere. My preference is to use the this keyword. So the this keyword lets the compiler know we are using this object's member variable. So it differentiates the fact that we're using this age, which is the class person's age, versus the parameter age. So you can see now that this age is colored one way and this age is colored another way. And again, this is fully personal preference. If you would rather say underscore age and do underscore age, that is perfectly viable, and you just pick what works for you and keep it consistent. Okay, now that we have a setter for age, we're going to need a getter so we can access age in program, because now it's inaccessible. So let's create public int get age because we need it to be accessible. We need to return the age. We don't need to take any parameters because we already have our age variable here, which was set by our setter. And all we're going to do is return age. So now we have a way to set our variable and we have a way to get our variable. Now in C# there is another way to do this called a property, which in my opinion is way easier and way better, but this lets you know how a property works. So I wanted to show you this first, and we're going to learn properties in another video. So now we can jump back to our program class, and if we needed our age, instead of doing this, we would have to say int age equals person.getAge, and then we could get our age that way. The next thing I want to talk about are private methods. So if we go back to person class, you can see every method we created is public, and we wanted to because we needed to be able to set and get all of our variables from another class so we could use our object somewhere else. But these are extremely simple examples, and oftentimes your methods are going to be very complex, and you do not want all of your code to be in one method. You want your logic to be very concise and separated into its logical parts. So sometimes you need private methods that the public methods can use. So let's suppose that we wanted to be able to return the description of a person. So we would want to do that publicly because we would want to get it somewhere. And we might say get description. But let's say that building this description is extremely complicated, which I know it's not, but for this example, let's just pretend it is. So let's separate some of our complicated logic off into its own method, and let's make it private. We're going to return a string. Let's call this build description, and we're going to return, let's say, first name plus last name plus maybe a comma, and then plus the age. So we'll get the full name with a comma and then the person's age, and we'll call that our description. Now in get description, maybe we have our description base is description, and now we can get our actual description with our private method like that, and then we could return our description base plus our description, and we would end up with the word description with a colon followed by all of this super complicated logic down here. So while I know this example is kind of crazy, hopefully it shows that you can break up your complicated logic into sub-pieces, and some of these sub-pieces do not need to be accessed from anywhere except for the method that's defined in the class as public. So you can use private to hide these methods away and keep them only accessible from where you need to use them. Now let's go ahead and see this in action. So if we go back to our program, first thing we're going to need to do is set our age, because we're trying to get it before setting it, and that's a big no-no. An int defaults at 0 even if you do not set a value, which saves you from things like this sometimes. But a lot of times if you try to get a value that's not set, you're going to crash your program. So keep that in mind, but we'll deal with that a lot better in some future videos. So for now, let's set our age, and let's just set it to 99. And our setter does not return anything, so we need to delete this. So now we have a name and an age. Instead of using our getFullName method, let's use our getDescription method. Let's put a breakpoint here, and let's run it. And what I want to do is I want to step in. So I'm going to step into the getDescription method. Now what we're going to do is set our description base to description. And now we're calling another method that I can step into. So now we're going to build our description. in which case we'll return all of our variables there, which then we'll have our base, which is going to get added to our description. And that, when we come all the way out, is what is going to get printed into our console, just like that. So now you know what the public and private access modifiers are, what they do, and why you should use them. And in my opinion, for a beginner, that's going to get you a long way, even keeping with best practices. That being said, if you are aiming for an entry-level job, then these might be in your face from day one. So while we will go over the depth of these in future videos, it's good to start getting familiar with what they are and what they mean. So let's start with protected. The protected access modifier is very similar to private, except this one is used with what is called inheritance, and that is also a core object-oriented concept. Now, while we will learn a lot about inheritance in a future video, the gist of inheritance is that you may have a class dog, and that class dog may inherit from a class animal, because a dog is an animal. So you may have one class that defines properties about every animal, and then you may have a class that defines only properties that have to do with a dog, but dog can inherit all of the properties from class animal because dog is an animal. So how it works is that protected is very similar to private in that if you define a protected variable in animal, no other class can use it except if something inherits from that class. So if dog is an animal, then dog could also use any of animal's protected variables, but no other class could. So next up we have internal, and we've seen internal because it is the default access modifier of class. Now internal is basically the same thing as public, but for only one project, we'll call it, and it's technically an assembly. So our project beginner tutorial builds an executable. Now, if we added another project, it would either build another executable, or it could build what's called a dynamic link library, or DLL, which is basically supporting code for another project. But those projects would be considered separate assemblies. So if you define an internal class in beginner tutorial, any other project you create, the code could not access that internal class unless you changed it from internal to public. So it basically keeps the class restricted to one project. Protected internal can be a little more confusing because the internal part does mean it can be used in any class in the current assembly, so protected is not very similar to private anymore. So the protected portion of protected internal comes in to where the inheritance comes in. So now we're on the assembly level, so that if it's protected internal, it can be used in any class in the current project, but it can also be used in classes that it inherits from. So say animal was in beginner tutorial, and it had a protected internal field. Well, then you had dog in a different assembly. Well, then only that class dog could access the protected internal variable from this animal class in beginner tutorial. Private protected, honestly, is what I think protected internal should be, and that's that it's more private. You can only use it in the class it's in, or classes derived from it, just like protected, but you can only do that within the current assembly, similar to internal. So be very careful with the definitions of these last two, because they work a little differently because they're on the assembly level of access restrictions. And again, I will reiterate, these last four are a bit more complicated than public and private. And if you are truly a beginner, just keep these in the back of your head for now, and when we get to the examples that use them, they'll be a lot more easy to understand. So the last thing I want to go over is very important, and that is the default access modifiers. So on a class, internal is automatically added when you add the class, but it is also the default. So if you delete internal here, the class is still internal. If you want to be able to access this from another assembly, you have to specify public. If you don't, then you don't have to specify internal because it is the default. But if we're in a class, the default access modifier for everything in this class is private, which is why we haven't ever had to write private before. All of the variables we've used in the past have automatically been private by default. So we don't have to have that word private if we don't want to. So that wraps up the basics of access modifiers. I know this was a very long video, but hopefully it was helpful and understandable, and we'll get to more details about the last 4 later. So next time we're going to work on constructors of methods. So thank you for watching, everybody. I do appreciate you, and until next time, as always, take care.